Okay. Alright, so 5.5. So I really did look through this and I couldn't figure out exactly what it is that was new. And then I found power functions. Alright. So I said, okay, so then I kind of looked at it and I go, that's what they're after here. So, let's talk about what a power function is here. So anytime you take a function and you go x to a power, okay, that is a power function. So you've seen quite a few of these. If you think about it, you've seen like x squared, that's your parabola, right? And x to the third is like a little cube root thing, okay? And then you have x to a fraction. X to the 1/2, what's that the same as?
X squared, or square root of x.
Square root of x, right? So if we have y equals x to the 1/3, then that's the same as y equals
X, cube root of x.
Cube root of x. Alright? So those are all power functions. Y equals x to the -1. How about that? What is that the same as? Y equals 1 over x. Very good. And that's a rational, which we did. So you see all these that we've been doing are kind of power functions when they're written in that kind of form. And that's what they're trying to get at here. All right, so these are all power functions. But there really isn't a whole heck of a lot that they do with these that you probably couldn't really do without really me having to tell you, because you could probably just do it. So they ask some questions like, if possible, evaluate each root function f at the given x value when the result is not an integer, approximate it to the nearest hundredth. Okay, so I'm just reading right off where it says. So let's say they give you like a f of x equals the square root of 3x minus 4, and they say, well, what is x, or what is equal to when x is 5? And then they say, well, what is it when x is equal to, say, 1? All right. Well, so let's look at it. So if x is 5, heck, all I got to do is put 5 in there, right? Three times 5 minus 4, 11. So it says, when the result is not an integer, approximate to nearest hundredth. So then I would take my calculator, or Desmos, or whatever it is you're using, find out what the square root of 11 is. What is the square root of 11? 3 point... Nice, Stephanie. 316. So we got to bump that up to 2 then, right? Because it wants to go to 100th. Okay. So that would be that one. So now we'll try 1. So then I'll put 1 in there. So 3 times 1 minus 4. Well, that's equal to the square root of -1. Oh, can't do that. We can't do square roots of negatives. So we would say no, non-real answer. Because it does say if possible. So there's going to be some that would probably be not possible. Then they go on, and of course they do their 5th roots and 4th roots because they like these. We'll do a 5th root. So we'll do x equals 2 and x equals negative 1. So again, all I'm doing is putting these numbers in for x. So 2 squared minus 4. So that's just the square root of 0, or fifth root of 0, which of course is going to be 0. Nothing earth-shattering there. So now we'll put negative 1 in there. So we'll go f of negative 1 equals the fifth root of negative 1 squared minus 4, which is negative 3, fifth root. Right? So far, so good? Okay. So now I take my calculator and find out what the fifth root is of negative 3. Because it's an odd, so you can do a negative on that one. So it's going to be 1 point something negative.
Negative 1.24 or 25, sorry.
Okay. So there really isn't anything to those that's a whole lot different than what you'd been able to do anyway. Okay. And then they keep going with this idea. So then they say, okay, we're going to do the same thing, except this time we're going to write it as a power function, so like 2/3. And so we want to know when x is, say, 4, and when x is negative 2, we'll say. All right. It doesn't change anything, though. You're still going to do the same thing. Just going to substitute 4 in there and replace it. 4 to the 2/3. And it doesn't say, it just says to evaluate it. I'm looking right at it. So I'll just take my calculator. 4 to the 2 divided by 3, if you do it that way. Otherwise, you use your x to the y or y to the x key or something. Does anybody, or yeah, I can use Desmos on it. Works pretty nice too. Just type it in. 2.52. Okay. Then I just do the same thing with the negative. So I'm just going to go f of negative 2 equals negative 2 to the 2/3. And just do the same thing. Make sure you put parentheses around that, though, or else it might not do it correctly. Negative 2 to the 2/3. What do we get there? There we go. So again, all you're doing is just substituting things in. Let's see. So I think they want you to do some domains. So let's do that, but I can't, well, I guess we can. So they want you to write the domain. We'll say f of x equals x to the 1/5 power. All right, so then what I'm going to do is just graph it. Take a look at it, see what it looks like. So we'll go ahead and put that into Desmos. So you're going to go y equals x. I know there's like a little, like a to the b power or something like that. Gotta give it to you. I think it goes a to the b. Or maybe it's b to the a. I think it's a to the b.
All real numbers.
Anybody get it yet?
All real numbers.
So the graph should look something like this. Yes?
Yep.
So yes, the answer is all real numbers because it covers everything. Here and here, everything on the x-axis gets covered. Okay, so that's all real numbers, yeah. So they want you to do it, and I don't really care if you say all real numbers, that's fine with me. But they're all into this integral notation, so, and some of you guys like that too, so we'll do it that way. I really think that's all there's just, that's pretty much all there is to that section. Just talks a little bit about power functions, domain ranges, evaluating them, just using your calculator. I don't know what to say. Any questions on it? If you want, you can look at page 380 and see if there's something there you're not sure how to do. Find anything on 380? Is there anything that you don't like, don't know how to do, not sure about? Okay. Is it 7/5?
Yep, negative 7/5.
Okay, so then what I'm going to do is go f of negative 32, put that in there. Negative 32, make sure I put parentheses around it. If you use some type of a calculator or Desmos or whatever you want, to the negative 7/5. If you're going to put it in your calculator like this, you got to make sure you put parentheses around that whole thing there. So let's see. It's going to be a pretty small number relatively.
Negative 0.00781.
0.00781.
0.07812.
Approximate the answer to the nearest hundredth. Then I would do the same thing with this one. Making sure that I put parentheses around that 7/5 so it takes it to the whole power. I don't need parentheses around the 10 because it's positive. When it's negative, I probably should. Just 0.01.
0.04.
Hmm? Maybe I'm thinking of it.
I've got 0.0398.
Okay. What are we getting?
0.04.
Not negative. Any other questions on there? Good one. 14?
Yeah, 13.
Which one you want? Pick one we have to do.
That would be 13.
So f of x equals, is that a fifth root?
Yeah.
4 minus 3x. X is negative 3. X is 1. So then we're just going to put those in. So negative 3 times 3 is going to give us what are we going to get underneath this, the fifth root sign? Yep. Take the fifth root of it. Rhyme to the 100th again. Well, I don't think it's more than.
I had like 10.
So it's got to be 1 point something.
1.67.
Okay, that makes sense.
Yeah, that's what I got.
1.67.
So then if we do the 1, so this would be f of 1 equals the fifth root of 4 minus 3 times 1,
Which is 1.
which is 1. So again, all you're doing is just substituting that in, taking the fifth root of it, or cube root of it, or square root of it, whatever it is. Any other questions on that particular section? Okay. Hey, let's go stretch some legs out. We drink some water. Okay, and we'll come back and do our last section on solving, which will be a little bit more challenging.
So I sent you an email saying I wasn't going to be here for the test, but I was looking at the wrong date, so I am going to be here for the test.
Because it's next Friday, Monday?
Yeah, I'm not going to be here for the next class though, so that's kind of worse
Wednesday.
for me.
So, I'll just kind of post a review for you then,
Yeah,
and
that'll
you can just get it.
Yeah, that's what I'll do. I'll have time this weekend to go over the book anyways.
That's good.
This pen's been like
Oh, yeah, I was
ever since
working on it. I have a screenshot.
Great.
last term. Just keep getting shorter and shorter.
She's gonna send it to me.
Yeah.
Sweet.
I just can't get this thing to fix it. I mean, I figured out how to do it, but I just need to figure out how to put it.
What do you got so far?
I have to do.
You kids.
So just.
Yeah.
Yeah, maybe she, that X plus 4, X and then put a point 1.
Those are with the nice things.
Oh, it's like
That's like
Sure.
the last thing I do.
Oh, okay. I get it.
It's just got some pictures, it's like the that's one that was.
Yeah. I don't know what would you like, what did I do last time? I think you guys wanted answers, right? So that way you get a blank one. You can run over to it.
Yeah.
That was the first. It was about 9 miles in presentation.
So I wanted to see if I can take my quiz 5 after class.
You want
Can I
to
do
do
it
your
today?
quiz 5?
I think that's what I'm missing.
Yeah, we can do all that. No problem.
Okay.
Sure. It's just, it's hard to find it. I didn't know that they're now I know. Now I know where I'm going. Now I know how to play this summer trip. I want something that's
339.
relatively close.
What the heck? What if that's the one that's not due till now? No, that doesn't make sense. 295. The hell? I can't. It's gotta be 3. Oh yeah, it's 5.1. I just, for some reason, I saw it.
Right.
Hmm. Okay, so we're going to solve some radical equations here. All right, so those are equations with radicals or square roots and roots in them. All right. What I'm going to do is start out with obviously some simpler ones and then progress. There's a couple of times where they get a little bit tricky, so we'll take a look at some of those. They also want you to solve some graphically, and I'll show you some of those too. Alright, so let's start off with solve square root of x plus 2 equals 6. So something like that. It's a simple little radical equation. The strategy doesn't change. We still want to do the same thing. We're trying to get x by itself. Alright, so then we're going to subtract the 2 first to get rid of that. Now we just have the square root of x equals 4. And then, how do you think you get rid of a square root? Square it. If you square this side though, you got to square that side. There it is. So the idea is solving equations still the same. We're trying to isolate the variable in this case. So we're going to do everything around it, try to get that square root by itself, undo a square root by squaring. Okay, so now we'll do one like this. This time the 1 is inside the square root, so it's inside that little bar there, not outside of it, so we can't add or subtract it. We have to leave it there. But what can we do first to get that radical by itself? Yep, divide by 3. That gives me 4. Okay, I still can't do anything with the 1 underneath there. So I'm going to go ahead and have to square it. Square the square root that goes away. I'm left with this. Now I can finally get rid of the 1. There we go. Okay, now we'll do one like this. Square root of 3x plus 3 equals 2x minus 1. So it gets a little bit more complicated. Alright, so we can't add or subtract anything to either side because there's just nothing for us to do there. So what we're going to do is just square it. Get rid of that radical. So that's going to be 3x plus 3. But what about on this other side? Right. So we're going to have 2x minus 1 squared. Okay? Now you have to be careful and remember that's just not 4x minus or 4x plus 1. You really want to take that, write it twice, and FOIL it. Okay? So you have to be careful with that. So that's 4x squared, right? Yes, that's true if we combine those. Okay, so what we did is we took the 2x minus 1 and we FOILed it, so we have 2x times 2x, that's 4x squared. 2x times 2x is 4x squared. Then we have 2x times 1, so that's a negative 2x. Then I have negative 1 times 2x, that's another negative 2x, which gives me the negative 4x that's there. And then the 1 times the 1 gives me the positive 1. So that's where all that stuff came from. Looks kind of messy now, but it's kind of neat with the color coded.
And then you move everything over to one side and solve for 0.
Yes. So now what we're going to do, yeah, it's a square, so we got it, right? So we're going to move this 3 over and this 3 over. And it's a good thing I copied this one out of the book because there's no way I would be able to make up one of these. So now I have that. So we're just moving everything over, setting it equal to 0. And now we get to factor this. So let's see. Should we go with 4 and 1 or 2 and 2 and 2? What do you want to do for your first one?
2 and 2.
I like it. I think it might work. This one's, I got a 1 and a 2. So let's see. We get 4 there. I get 2 there. Rats. Didn't work. And it really wouldn't matter if I switched it around. If I switched the 2 and the 1, because I'm multiplying by the same thing. So, guess we got to go with the 4 and 1. 4x plus 1 and x minus 2. See, that's a 1x there. I got that. Oh, yeah, negative 8x there. Yep, that works. Good deal. Okay, so what's one of my answers?
X equals
Negative 1/4. That comes from here. And what's the other answer? X equals 2. Now, when you get to some of these, the simpler ones probably not so much, but these ones, where you're squaring both sides and you got a variable, you want to check to make sure that they work, because it's possible that it doesn't work. So I'm going to go back up to that original equation that I had. And I'm going to check it. So I'm going to put 2 in here. 2 times 3 is, we're checking. 2 times 3 is 6, plus 3 is, and the square root of 9 is, so that's good. 2 times 2 minus 1, does that work out okay? 2 times 2 is, minus 1 is, there we go. So that one worked. It doesn't? How do you know that? Oh, what'd you get? You just did it. It didn't work. So let's see. This is going to be negative 3/4 plus 3, right? So that's the square root of...
It would be 2x minus 1.
Well, wait a second. But what about the square root? So you took 3 times negative 1/4, right? No, you could be still right. But, so we got to check to see if both sides work, right?
Right.
So if we go 3 times negative 1/4 plus 3, I know that's negative 3/4 plus 3. What's the square root of that?
Big number.
No, it should be pretty, no, it shouldn't be too big. 2.25? No, that's, but you got to square root that.
Negative 3/4 plus 3.
Negative 3/4 plus 3, square root it, yep.
1.581.
Now if I go 2 times negative 1/4 minus 1, I bet that doesn't turn out to be 1.51, but check it out. What is 2 times negative 1/4 minus 1? What's that? Well, I know this is 0.5 negative minus 1. Should be negative 1.5. But they're still not the same. So 1/4 is no good.
I got it. Maybe it's just because I was using my phone calculator. I got negative 1.5 for the first.
You got negative 1.5 for this one too? Well, it can't be negative. That's a scary thing. Because the square root of, this is going to be the square root of 2 1/4. I know that. And I think that's 1.5. Right?
My calculator gives a fraction, so.
Does it give 3 halves?
3 halves and negative 3 halves.
Yes.
Yeah, it gives 1.5.
So 1.5 is this one. This is negative 1.5. But what are we going to conclude then about the 1/4? Is it good or good? Is it good or not?
It's not the same.
Not the same.
Negative.
So,
Same.
not a solution. We pitch it. Okay? So the only thing that works is the 2. Okay? The negative 1/4 doesn't work.
How do you know it's the negative 1/4 that doesn't work?
Because that's the one that we substituted in here.
We just checked it.
Oh, yeah, of course. Sorry.
Okay, that's all right. Yeah, that's the one we checked. So when these things get more complicated, you got to check them. See if they work.
So when we get 2 answers, check them.
Yep. I don't know if you'll have any with one answer. You'll check them. It might be possible. What you really want to check them when you have a variable in the square root and a variable out here. That's when you want to check them. Okay, what about... I don't want to do that one yet. Let me find another one. Okay, let's try this one out. So we're solving. Can we do anything initially, or what do we do now with this? Gotta square it. Okay, so right away when I do this, I got an X there. I see I'm probably gonna have to check this. Make sure it works out. So I'm squaring. What am I getting then if I square this stuff? 4 minus x equals x minus 2 squared. Alright? So be careful. Make sure that you write it twice and FOIL it. So we're getting x squared. What else are we going to get? Minus 4x plus 4. Good. Move everything. So we move everything. What do we get there?
X squared minus 3x.
Oh, what happens to the 4's? They cancel each other out. Alright, so we'll pause here for a second, make sure you see what we did there. Okay, so we squaring the x minus 2, write it twice, FOIL it, take your time and FOIL it, then move stuff over. Okay, this is set equal to 0. Factor out an x. There it is. What's one of my answers?
X equals 0, x equals 3.
Okay, so I got 0 and 3. I factored out an x. I got 0 and 3. So now I need to check them. Got to make sure that they're both going to work out. So I got to check them.
0 doesn't work.
0 doesn't work. Why isn't 0 working?
Because 0 minus 2 is negative 2, and the square root of 4 is 2.
So if we check 0, that's 2, and 0 minus 2 is, yep. So 0 is no good. Can't use it. Okay, now we should check 3.
3 works.
So 3 is okay. All right. So again, anytime we have a variable and you know, on the outside that square root equal to it, we got to square both sides. We're probably going to get one that doesn't work. All right, that's just how it works out. And because you're squaring, you're introducing another possible answer. That's what's happening. Okay. Questions on those ones that we've done so far before we do even a harder one? Sure.
One that has more variables, like the first one you did.
I'm looking for one. Those I just can't make up off the top of my head very well. So here, how about this one?
What page is it?
2 equals x minus 11. How's that one? Is that one okay? All right. Okay. Obviously, what are we going to have to do with this? So what do we get? Going to write it twice.
Squared minus 22x minus 22, or 121.
Yep. Okay, so we squared it, wrote it twice, FOILed it carefully. Start moving things over. When we move things over, what are we going to get?
Yeah.
119,
Yeah.
but we're subtracting 2, aren't we?
Yeah.
Okay. 119. I would have thought that was prime. What?
Pretty sure it is.
Where's that at? 2x plus 2 equals x minus 11. Huh. I don't think anything goes into 119. 3 doesn't.
You are correct.
I'm correct. Nothing goes into 119?
Well, no, I'm just saying, it's, yeah, they'll have to.
Could you solve that with quadratics?
Shoot, I could have made up one as nice as this one. I'm trying to, gosh, I don't see anything that goes into 119, but I don't see anything I did wrong. I just checked the problem. I wrote it down right.
You got a cool button.
Negative 17 and negative 7.
17 and 7 work?
Negative 17 and negative 7.
Nice, it does go in there. I knew there had to be something with it. 7 and 17, that's craziness. Okay. So what's our answer then?
X equals 17, x equals 7.
Better check them. So we'll check 17 first. I know 17 is going to work. I can see it. Yeah, that's 6. And that's 6. So 17 is a winner. Now we'll
7 doesn't work. 4 equals negative 4.
Yep, we're going to get a negative there. There's no way we're not going to get a negative on this side. So we pitched the 7. 17 is the right answer. Okay, last one. Let's try one of these. Double checking here. Okay. Square root of 2x minus 1 equals square root of x plus 1. All right. Okay, there we go. What should we do on this first? Yeah, because if we add 1, we're really not gaining anything. We're just pushing it over to the other side, so it doesn't do any good. So we just ought to square them. When we square, what are we going to get on the right side? That's nice. But on this side, we're going to get that. Okay?
2x squared?
So I'm going to have to write this twice. So I multiply those two things. What is that going to give me?
4x squared.
So the square root of 4x squared is 2x minus what happens when I multiply these two.
1.
So I get 1 times the square root of 2x. So that's a negative square root of 2x. Does that make sense? Right? So we're taking this 1 times this one. Okay. Now we'll take this one and this one. What does that give me? Yeah, square root of 2x again. And then finally, what do I get when I multiply those two things? Okay. So let's pause. So we took square root of 2x. This whole thing's over like that. Squared, wrote it twice, foiled it, so the square root of 2 times the square root of 2 is 4x squared, but that's going to be 2x because the square roots are going to go away. Minus 1 gives me a minus 2 square root of x, and then I get another one of those, and then I get a plus 1. So it doesn't look like it did anything really very good. Do the square roots cancel? Nah, because they're minus and a minus.
No, but they basically have an invisible 1 up above them, right?
Correct.
It's like 2x minus 2 square roots of 2x.
Correct.
Plus 1.
Yep.
X plus 1, and then you just move the x plus 1 over.
So then what we want to do is move that 1 over here, and this guy, this 2x over, right? Okay. Ones are going to go away. Oops. So I get that. Subtract 2x from both sides. I get negative 1x. So it doesn't really look like I've done anything because I still have a square root. So what do we got to do to both sides? Square it again. Bet you're hoping you have a bunch of these on that test. No.
Do we have one?
Probably. Okay. Well, what's negative x squared? What's that going to be? Just
You mean
x.
negative
It's just going to be x squared, right? Okay, good. Now we're squaring this. Okay. So we're going to square. Here's how we square this. We square this number first, and then we square that thing. So what is negative 2 squared? 4. And what is the square root of 2x squared? 2x. So we're finally getting to the end of this. So now I'm going to shift that over, set it equal to 0, and 3 minutes later, I get an answer. Guess what we have to do with them?
Check it.
Check them.
Do you have to go all the way back up, or could you just say 8x equals x squared and just put them there?
Because you know what the answer is then?
Well, I mean, do you have to take the 0 and the 8 all the way back up to the top? Or could you just fill them in at any other point?
Got to go to the original.
Is this on the book?
Yeah, Victoria, I'm not making this up.
What number is it? Just want to make sure we're counting.
It's on 386, example number 4. You making sure we're doing it right?
Yeah. I learned differently.
You learned it differently?
I said I learned different.
Oh, okay. That's all right.
Talk about this.
It's in there. All right. So check it out. Does 0 work? Put it in the very first thing we did. Whoa, way up here. There it is. You think 0 is going to work?
Who knows?
No.
5 minutes later.
I know I told you 5 minutes later. So 2 times 0,
0,
square root of 0 is
0,
minus 1.
negative 1.
Are we going to get a negative 1 when we square root anything?
No.
0 is no good. Better try 8. 2 times 8,
16,
square root of 16,
4,
minus 1.
1, or 3.
Square root of 8 plus 1 is? Square root of 9 is? It works!
Ew.
Yeah, it worked.
Good job, us.
Yeah, good job, you. Okay.
What now?
So, oh, well, what now? That's the best part now. We'll graph it.
Is that the hardest that it gets? That
Yep.
one? Yes.
Is there graphing on the test?
Is there graphing on the test?
This one.
You're like 50,
Are we graphing
15.
these on the test?
You're going to graph some of them, yeah. Not sure which ones. We'll graph this one.
No, everybody else is wrong.
So let's see, 2x minus 1. Put that one in there. Now I'll go put in the bottom half. Y equals square root x plus 1. And what are we looking for?
Where they intersect.
8.
Why don't we do that?
It's too easy.
I didn't say you couldn't.
Well, can we do that instead of this?
You can for some of them.
Instead of 5 minutes later?
Can we use it to check?
It's the joy of mathematics, Victoria. It's that challenge.
Can we graph to check them?
Smoke,
Yeah.
smoke, that's my brain.
Yeah. The good news is you don't have very, there's not very many of those. There's just one or two.
God.
Only watched it.
Okay. There's just one or two of them.
I wrote it down wrong, that's what happened. I was so
Not for me.
confused.
Oh, you wrote it down
I don't know
wrong?
how
Oh, so you're good?
Yeah, because it's like, what? How is this? I put the whole thing square root 2x minus 1.
Oh, yeah.
So I was like, what's going on? I'm so confused.
Oh, want to do that one?
No.
Oh. We could. I don't know how it's going to turn out. It might be fun. Could be a fun one to do. I don't know.
Okay, let's do it.
Let's see. Oh, they have some of these too.
Because I got 2 for the answer.
Did you?
Yeah.
That probably works.
Yeah.
Yeah, cool.
Because I was like, I got 2. How did I get 8?
Okay, how about ones like this? 4x squared equals, oh, sorry, my bad. Nobody said anything. 4x squared equals 32. What do we got to do first, you think? I'd probably do this first, but you could. Get that x squared by itself. 32 divided by 4?
8.
8. Now we'll square root.
Plus or minus? Did you do the plus?
Yes. You should put the plus or minus there because it's 2 answers. Okay? Yes, definitely. Put the plus or minus there because it's 2 answers. Okay?
Plus or minus 2 square root 2?
Yeah.
Do we simplify it or do we?
Yeah, you probably should. The book will.
Talking about. Sure you should.
Okay? What do we do on this one?
Boil the.
Watch this. What if we did this? What happens to the square root in that square? So we get x minus 3 equals the square root of 7. But as Victoria's pointed out to us, we got to put plus or minus there. Now we're just one step away. So what do we get?
So 3 plus minus square root of 7?
Yep, and that's all we can do there. We can't do anything else. Okay.
So can you add the square root to everything that's square? And just drop it?
No, you got square root first. Is that what you're asking me? Like where?
Maybe you had the x minus 3 at first squared and then you added
Uh-huh.
the root, well then you just dropped it, x minus 3, instead of boiling it.
If you FOIL it, you would then you swap the 7 over. You could do that, but then you're just going to end up with this. It's not going to factor. You'd have to use the quadratic formula or something, which we don't expect you to know, I guess. I don't know. But when it's like this, it's just as easy as just square root it. Okay? But you wouldn't go wrong by using the quadratic formula. It'd just take a little longer. 5 minutes. Okay. I could maybe find another one with a double square root in it if you want to see another one, but other than that, that's it. Bree says no. No. It's too much fun in a day, huh? So we're good?